Hi, in the previous tutorial, I have already demonstrated how to install QGIS and QSWAT. So today I'm gonna start developing a SWAT model from scratch using QSWAT. So here you can see after installation, you will have access to this QSWAT toolbox here, and if you open your QGIS, and then you'll get this. If you don't see this flag in here, the module QSWAT, you can click on plugins and then manage and install plugins, and here you'll be able to see the list of installed plugins. And if you don't see there, you'll see that these are not activated, and if you click on these and if you check this on, automatically you'll get access to this SWAT and SWAT Plus as well if you have already installed those. If you didn't see my previous video on SWAT installation, you can watch that video and go back to this video as well. So I'm gonna click on the add QSWAT. So here I'm gonna create a new project, click on new project, and then try to save and select a directory, right? So I have data there, QSWAT, and inside this QSWAT I have this DEM data, because we'll start with this DEM, then we'll delineate our watershed. So I'm going to create a new folder named QSWAT, okay, and basically it is QSWAT and QSWAT model. Then I can select it and open, and inside that one I'm gonna create a model for the watershed called San Jacinto. Okay, it is located in Texas, USA. So that's why I'm gonna give the name as San Jacinto watershed. And if you hit OK, it's gonna create everything. See, you have the options activated. First you have step 1, step 2, step 3, and you have more steps. But first, see, only the step 1 delineate watershed is activated, but these are not activated because we don't have enough information to create this HRU. At first we have to delineate our watershed, then this option or step 2 will be activated, that hydrologic response units. So first click on delineate watershed and it will ask for the DEM. You have to have this DEM. So here it is gonna ask you to select DEM, and I'm gonna locate this DEM there. So it's there inside my DEM data, and then I'm selecting this .t file. So here it is, it's gonna load, and you can see there is the map of the DEM. I have already demonstrated HKSMS model for the same area. If you didn't watch that videos, you can go back to my HKSMS playlist and you can watch all those videos. And that's why I'm gonna even develop this model for the same watershed, so that we can even compare the results and we can test the performance of these two models. And after selecting this DEM, right, it is asking to give you this option. If you have your stream network, if you already downloaded this stream from some other sources like NHD Plus for USA or for your country or for your watershed, you can even download. And if you get the stream network, you can use those stream network to burn your DEM to delineate a watershed. But for this case, since I'm starting from the beginning and from scratch, I'm not gonna select that options. So here I'm gonna give the threshold limit of watershed. The minimum area of a watershed will be 100 square kilometer. Okay, if I select that, and then if I hit this create streams, then it will start all the processing, right? If you have idea on watershed delineation using ArcGIS or ArcHydro, basically here it's the same thing, but it will do the same things behind the screen. The background calculation will be done, like sink dam, then it will delineate flow accumulation, flow direction, stream delineation, stream segmentation, drainage network, right, and all these things. And after that it will perform watershed delineation based on our output location. So that's why first we have to create the stream network. If you click there, it will use this threshold value, and then it will take a while, and you can see here all this processing is going on. See, flow direction is going on D8. So it uses 8 directional values of flow direction, right, for north, south, east, west, and 4 corners. And based on that 8 values, it will calculate the flow direction, and then it will perform flow accumulation and stream segmentation and drainage network, and then you will see the stream network on this DEM. So that takes a while because it is performing 4 steps or 5 steps to show you the stream here. But before that, what you can see, we can go back to our folder, right, where we created our model. So inside this folder, we have this model name San Jacinto. So this is the file, that is QGIS file. So we are not going to focus on this one. So if you go inside this San Jacinto folder, you will see several subdirectories. So scenarios, inside these scenarios, you'll have different scenario. In future, we'll see that if you have tables, input tables, output tables, and your other information will be there. The results and everything will be there in this scenario. And then you have sources, right? So currently, if you have different sources like input values, input data, like crop data, your soil information, land use information, and all these calculations are just performing behind, it is here, right? The DEM, and it also performed other hillshade and everything. So it will be added there. And if you go back and if you see the watershed, so here you can see the grid. Recently it's empty, and here you can see the chef file. All these chef files will be there, but for the time being it's empty because there is no chef file for stream network. And tables, right? You can find tables here when the model will be completed, and then you have temporary files, and then you have other text files here. So when you'll be done, and you can see all this model database are there, it generated all these files. So let's check. I think it's not gonna finish shortly because it's pretty big watershed, and the threshold we already assumed is 100 square kilometer. If you even have a dam that is more sophisticated, because this is a 10 meter DEM, it is high resolution DEM, but for your study area, if it is like 30 meter, means 100 feet, it's okay for large watershed, because sometimes if you have very fine high resolution DEM, it will take a lot of time, but the accuracy won't improve. For other models, it needed for gridded model, but for watershed model, these models are kind of a lumped model. It is a semi gridded model. So it calculates based on hydrologic response unit, but in HEC-HMS model, the calculation usually performs based on sub basin if it is not gridded. But for HEC-HMS, it has that option for a gridded model as well. So for lumped model, it will work and it will calculate as a semi gridded model, because it will calculate based on that hydrologic response unit, and it will generate the hydrologic response unit based on the land use information, based on the soil information. That's why to set up this model, you will need not only this land use and soil information, you need even climate information as well. So the main forcing for this model or any hydrologic model is precipitation. And if you have observed precipitation over this watershed, you can use those. Or if you don't have that for USA, you can even download directly from the internet, and we have the link there. We can download those. And for soil classification, we can even download all this information directly from website. But if your study area is located outside of USA, then you have to even generate all these input files. In my future video, definitely I'll try to show you step by step how to even generate all these input files other than just directly using the general values from the website. If you have observed value, that is even more accurate. But if you even download something from a website, these are the reanalysis data. So reanalysis data is reliable sometimes if you have the reliable sources, but it's better to even generate your own input files, because you need to know what are the files and how it looks like and what are the inputs. Then you can understand the basic parameter and the basic structure of the model, and you can fill the model that okay how it is calculating all this stream flow, because it even use soil moisture counting and other information for calculating these values. That's why you need to have those inputs, this wind speed at 10 meter height, sometimes at 2 meter. It depends on the necessity of the model or the equation it needs for calculating this evapotranspiration losses. And you need solar radiation, you need relative humidity, and you also need temperature, right? So you have to have all these values for your watershed, and then the model will automatically calculate the losses, and it will calculate the base flow, and it calculate the runoff, and the base flow and runoff will combine together to generate the stream flow. And you will have some watershed we'll see shortly, not now, but after delineation of this stream network, we'll fix our outlet somewhere here, and then we'll see the watershed. So the performance or the stream flow will be based on a sub watershed, and then it will accumulate at the outlet of any basin or watershed like this. So that is the idea, to estimate how much water will accumulate or outflow from this basin or watershed if we have any rainfall event, and if we have any sequence of rainfall event. If you want to run this model for a long time, for several years, 10 years and 20 years, then definitely it will use that soil moisture counting, right? It will preserve the moisture in the soil from the previous year, and it will just transfer this value to the next year, and the model will track those values, and it will pass these values to the next year. So that is called soil moisture counting. It is a 2-bucket model, and this model is the well established model for generating and calculating this soil means base flow and runoff from any rainfall event. So that's why even HKSMS, they have this, it has that option to use soil moisture accounting, and this model, it automatically use that. So after getting this stream network, we can draw the inlet. So for example, if you already know that okay, this is gonna be your inlet, or if you wanna specify inlet here other than here, so what you have to do, if you already have your point shape file for this location or for that location, you can even import that from this option. So use an inlet or outlet shape file if you already have that shape file. Or for this case, since you're right, we are just developing this model from scratch, so we don't need to import. We'll draw inlet or outlet there somewhere here when we'll get the stream network, and then we'll select it, and then we'll okay. Even if you don't need to select, if you import your shape file, then you can even select automatically by using this threshold limit. This is called snapping tool, right? If you specify 300, 500, and then if you put your outlet somewhere there, but your stream is not touching that outlet, then the model won't understand. So if you specify this threshold limit, the model will look for that outlet location, and then it will assume that okay, this is my outlet, so close to the stream, and it will select that outlet and it will delineate the watershed. So that's the idea, but you can't do both things. If you draw, you can select, and if you import, you can use this snapping tool. So these are the basic thing and sequence you have to follow while delineating your watershed, right? So it's gonna, I think, finish within few minutes. And let's check again the directory, because frequently it is generating different files, right? So you can see the shape files, still there is nothing because it's still working on that. And if you have anything there, sources, see, it already added this hillshed, and it added some text file, but in the soil it's empty because it didn't add anything, and crop, and there is nothing. This model is basically for managing any watershed. If you want to even add water to your crop, if you have any crop means irrigation schedule, so this model can account for that irrigation schedule as well. So this tool is pretty good to use as in an agricultural field, and hopefully it's done. And see, we can see the streams pretty clearly, right? And you can even manipulate the streams here, the width and the color, like GIS, right? Same thing. So now we know the streams, and next step, other than importing our point, right, as outlet, we can even draw the outlet here. Okay, then I'm clicking on that, and it is asking if it is outlet, reservoir, inlet, or points or point source. Since it is outlet, and if you have reservoir, you can select reservoir as point source, and if you have any inlet, you can do that. You can add inflow from upstream. So in future scenario, maybe we'll check that, but first let's use this point as outlet. Okay, then I'm specifying okay. So what you have to do next thing is to select that. Then your model, if you drag this, and it will be yellow. See, and now we are gonna save this selection. So it got selected. So if you import, then you can use snapping tool. You don't need that. Now it's selected, one selected. So if you click on watershed, then definitely it's gonna take that point as outlet, and then based on this point, it will delineate this watershed. Let's click on that, create watershed. It's not gonna take that much time because everything is ready, and then it is just delineating watershed. So this will be the step of watershed delineation. See, it's already snapped automatically. You don't need to even click on that. And finally, you see, you're gonna see this. So we have this much. We don't know how many watershed we have, but we'll see later on when we'll click OK. So after getting your watershed, if you see, okay, you are not satisfied with this delineation, you have some watershed that are very close to each other, and these are insignificant size, you need to merge them together. So how can you do that? You can even merge, okay? These watershed and these watershed I can merge because they have same common outlet point, right? This small watershed and this big watershed, right? So these two, they have this outlet point. So I can even select these two and I can merge them together. So that's why I'm gonna use this tool to select. So here, if you click on that, select Sub Basins, and it's gonna give you the what? It's gonna give you this text you can read. So hold Control, and then you can even select, and then you can see which one is being selected, and then you'll see the number of selection. Now see, I haven't used this, so that's why even though I selected, there is nothing, right? If I select Control, press Control and click there, it got selected, and now see 2 sub basins are selected. And if you have any threshold limit that, okay, select all those sub basins that has like area less than 20 kilometers square, so you can even do that. If you click on that, that is even possible to give all these areas. Okay, so we're not gonna do that. So we already selected 2, and if I save these 2 selections, and if I click merge, so they're gonna merge. See, they're done. Now we have only 1. Okay, so we have only 1 sub basin there. That's okay. So this is one option that, okay, how can you even merge them together? And then if I click OK, if you have any reservoir or any other point sources, even you can add those. For this case we don't have, so I'm not gonna click anywhere. Okay, so now if I click OK, so it's gonna finish here. So I'm clicking OK. So it's gonna give you the number and the ID and everything. See how many sub watershed we have, right? So we have 15, right? 15 sub watershed for this basin. So now you can see the step 2 has been activated. Okay, so when step 2 will be done, then step 3 will be activated. Then when step 3 will be activated, then we'll see another step 4 visualization. So this is how it is going to give you the option. So it is not possible to right mess up things, it will automatically give you the sequence. Okay, so the next step is to create hydrologic response units, but for generating hydrologic response units, you need to have soil information, you need to have land use information, and you need to have the soil classification and the soil groups information. So we'll do that in the next part of the tutorial, and then we'll move forward and we'll run the SWAT model and we'll use the input files and the climatology and everything. Okay, so that's that for today, and if you have any query or question, you can let me know. I'll try to answer your questions and try to replicate the problems. So thanks for watching and thanks for supporting my YouTube channel, and stay safe and take care.